Okay, we're now going to look at how the Doppler effect applies to our galaxy. And we'll kind of go back to the 1900s. Now, this is before even we had built rockets that had left our atmosphere, but we were still able to investigate both our solar system and the rest of the universe. Um, and what we did was we turned telescopes on our star, the sun, um, and we put the light that came from it through a prism or spectrometer to spread out the light into its separate frequencies. And what we observed was these little dark lines. We now know from the previous topic that these are absorption lines. Particular atoms will absorb very particular frequencies of photons or energies of photons, and that's how we get these dark lines in the spectrum from our star, the sun. And those lines relate to very particular elements. So maybe these two lines might relate to hydrogen. So we know that there's hydrogen in our star, the sun. And we see lines that are for things like oxygen, for chlorine, and different elements like that. We even saw some lines that we didn't recognize, and we maybe thought, okay, these are the element, maybe an element that only exists in the sun, so we called it helium. But then later we discovered that element on Earth. So without even leaving planet Earth, we were able to tell what our star, the sun, was made up of. And what we then did was we turned those telescopes on other stars in our galaxy. So we maybe look at Betelgeuse in Orion, we look at Sirius, some of the brighter stars, and what we get every single time we do that with stars in our galaxy is exactly the same pattern. So from that we can conclude all the stars in our galaxy are made from exactly the same elements, mostly hydrogen, a little bit of helium, and some of the other elements. But back then, people weren't too sure whether our galaxy was just it, okay? Whether the Milky Way and all the stars in it was everything there was. Those little splodges of light that people had observed, and they weren't sure what they were. And it wasn't until we got stronger telescopes that we could actually determine exactly what those things are. So our nearest galaxy is the Andromeda Galaxy. It's going to look with a weak telescope even, might look something like that, just a little kind of blur of light. But with a telescope we can see it's actually made up of hundreds of billions of stars. Okay, so it's a galaxy in its own right, very, very far away from our galaxy, the Milky Way. So what we then did was we decided, okay, let's look at light from some of those galaxies. And when we looked at light from other galaxies, we got a very similar pattern. Not exactly the same, but because what we saw was that pattern, that distinctive pattern from those very particular atoms, was all red shifted. So the light was shifted towards the red end of the spectrum. Now, it didn't matter which galaxies we looked at. So if we look at some of the brighter galaxies that they might have turned their telescopes on back then, I just bring up the search here. So let's go for the Whirlpool galaxy. Turn our telescopes in this, put the light through the spectrometer, we get exactly the same pattern we would have got for our star, the sun, only it's red shifted. Go to another galaxy. Exactly the same thing. Maybe shifted more towards the red side of the spectrum, maybe a little bit less, but always red shifted. And no matter which one, no matter which galaxies we look at, we get the same thing. Okay, and there are billions of galaxies out there that we can look at. So any star in our galaxy, we get this pattern. Another galaxy, we get the same pattern but shifted to the red end of the spectrum. Now, we already had an explanation for this, because we know that the Doppler effect doesn't just apply to sound waves, it applies to all waves. If an object is, if the source of a wave is moving towards us, then the observed wave will be of higher frequency. If it's moving away, it will be of lower frequency. And that's what's happening here. When light is shifted towards the red end of the spectrum, that's towards a lower frequency, longer wavelengths. And what that tells us is the source, i.e. the galaxy, must be moving away from us and must be receding from us.